So you're looking at quadratic equations, but this time it's actually asking you to answer a question that you'll need a quadratic equation to solve. There are some people in the world that can look at this thing and say, oh, I can see what the equation is right now. And they write it, and then solve it, and they're done. Okay. The rest of us have a hard time writing these equations. Sometimes I did when I was first learning to do this stuff. So what I learned to do was say, look, I'm just going to take a guess and try it, and eventually I'll either guess the right answer or hopefully I'll be able to see a pattern and write an equation. So I'm supposed to find a solution to this where it says 7 times a number is 18 less than the square of that number. And I'm like, what? What are you talking about? So let me just try this. I'm going to guess. I don't know. How about 5? Okay, so my number's 5. Okay. So what's 7 times that number? 35. Okay, and that's supposed to end up being 18 less than the square of that number. So the square of my number is 5, right? Okay, so 5 squared, that's 25, and then 18 less than that is that, right? So is it true that 35 is 25 minus 8? No, not at all. Okay, so I guess wrong. Okay. So let's try, I don't know, how about 10? Okay, 7 times the number is 70. Okay, and is 10 squared, because that's supposed to do 18 less than the square of that number, is 10 squared minus 18 equals 7? Nope, it's not. Let's guess again. How about, I don't know, 6? 7 times the number is 42, right? Okay. Is it true that that is, let's see, 18 less than that squared, so 36 minus 18. Is that true? Well, not 36, excuse me. 6. Okay. 36 minus 18 is not equal to 42. Okay. But here's the nice thing. Even though I guessed and checked and I got it wrong 3 times, 3 is the magic number for your brain to recognize patterns, right? Okay. After you've done 3 of them, your brain can say, wait. Every time I'm trying the same thing, right? I'm taking this number and multiplying it by 7, and I'm taking the number and squaring it and subtracting 18 and trying to make them equal. So I can either keep guessing until I finally get it, or I can say, how about if I just guess like n? Okay. What's 7 times the number? 7n. Okay, and then I was always squaring the number, so n squared minus 18, and I'm trying to get those to be equal, right? So I'll put an equal sign in there, and I'll go, cool. I just finally wrote an equation that I could solve and answer the question. Okay, there's our announcements. So now I can solve this thing, right? And you know how to solve that? Okay, so I'm going to pause there and say, okay, look, we got that. You'll solve it, and it says find the positive solution. There's 2 solutions, and they'll want you to enter the positive. Okay, so the other kind of problem you're going to see, another kind, this says the width of a rectangle is 1 unit less than the length, and the area of the rectangle is 30 units. So what I'm going to do is say, look, here's the width, and here's the length, and I'm just going to take a guess, okay, what the answers are. So how about if I just guess, let's see, the width is 1 unit less than the length. So if I say the length's 10, this would be 9, right? Okay, and then to find the area, you know how to find the area of a rectangle, right? Length times width. Okay, so in that case I get 90, and it was supposed to be 30. So survey says, got it wrong. You want to guess higher or lower? Lower? Okay, let's guess 8. 1 less than that is 7, right? Okay, multiply those together, you get 56. Is that 30? Survey says, what's it? I'm sorry? 10 and 3? Well, then 3 is not 1 less than 10. Okay, remember, the width is supposed to be 1 unit less than the length. Okay, so that guess wouldn't work. So let's guess again. Let's try 7. Okay, so suppose I use 7. Multiply those together, you get 42. Now, your next guess, 6 to 5, is going to work, right? Okay. If it didn't work, you could always say, let's just guess n, and this would be 1 less than that, right? Okay, and then you multiply those together, n and 1 less than n, and it's supposed to equal 30. Okay, and as soon as you write this as n squared minus n equals 30, you say, oh, quadratic equation, and I can solve that. Okay, now you're right. It's 6 and 5, and that's going to be the right answer. Okay, so you'll see that, and then this one's a little bit longer. You got to read a little carefully. Okay, it's just text. Don't freeze. It's just text. It's just saying things. Okay, only words. All right. So this company sells widgets, and the price of the widget is X, and this calculation here tells you how much profit you're going to make. Okay? Obviously, if you don't sell widgets for very much, you won't make much profit. But if you sell them for too much, you won't make much profit either, because people aren't going to buy it. Okay? So the idea would be, if you took a graph of this thing, you'd look something like this, right? So as you increase the price, eventually you break even, right? So you break even right here, and then it goes higher and higher and higher, and eventually it starts going lower, and you get down to making zero money again. Okay? What they're wanting to know is, when does the company break even? In other words, right there. Okay? So what's the y coordinate right here on this graph? 0. Yeah, it's on the x-axis, right? Okay. So I'm wanting to know, what's x when the y is 0? Okay. So we'll put a 0 in here for y and solve that quadratic equation for x. And I know. So if they ask you, what does it take to break even? You just put 0 in for y, figure out what x is. Okay. So put 0 in there, 0. Here's a quadratic equation. I'd use Desmos to do the heavy lifting for you. And solve. Same thing right here, right? What does it take for the company to break even? What are you going to put in for y? 0. So you put a 0 right here and solve for x, like you did before. Okay. The last type, this one says, this tells you the height of a rocket that you fired in the air. Okay, so x is the time in seconds. And this tells you how high it's going to be after whatever number of seconds you choose. And as you know, the rocket's not going to go up and up forever. It's starting at a height of 82, so it's going to go like this, and eventually back down. Okay, and they want to know, when does it reach that point right there, the maximum? Okay, well, I'm just going to tell you this for right now, and I'll worry about proving it later. I kind of hate teaching that way, but I need to move along. Would you agree that that point right there and that point right there are where y is 0? Okay, and this would be exactly halfway between them? Okay. Well, here's the deal. When you find these 2 points, you do this. X equals negative b plus or minus b squared minus 4ac all over 2a. You know all that, right? Okay. Well, when you calculate this, you start with this thing and you add this stuff. Okay, and then you start with the same thing and you subtract it. Okay? And what's happening is, you're starting here and you're either adding a certain amount or you're subtracting a certain amount. So if you just calculate this right here, b squared or negative b divided by 2a, you get that spot right there. Okay, so what I'm going to do is say negative b is negative 133 divided by 2 times negative 16. Calculate all that, and that tells you that spot right there. It tells you the time at which it reached its maximum height. Okay, or if you had an equation that told you the power output of an engine, finding that spot right there would tell you the maximum number of RPMs you should use to get the maximum power. So with all these things where it says, what does it take to make the maximum profit? Okay, all you have to do is calculate negative b divided by 2 times a. In this case, it would be negative 952 divided by 2 times negative 13. Calculate that, and that tells you your answer. So that's what you're doing for now. I'm going to have to stop it and move along. I'm going to record this, put it up on Classroom so you can watch it again at the end.